Let's take a look at what ratios are. So that's going to be the goal of this lesson. We want to be able to compare different quantities and to also use proportions to figure out missing parts of ratios. All right, so let's get into the things and see what we have in store. So first of all, there are some definitions, like what is a ratio? So a ratio is just a comparison of two numbers or measurements expressed in the same units. And like a fraction, ratios can be reduced. So let's do that. Let's go ahead and reduce some ratios. So again, when we reduce fractions, we look for a number that divides into both parts of the fraction. For a ratio, look for something that divides into both of our numbers. So if you have 20 and 24, well, you can divide both of those parts by 4. And if you do that, what you'll do is you will get a ratio of 5 to 6. And yeah, in terms of terminology, we say 5 to 6 or 20 to 24. That's how we say our ratios. All right, let's reduce this next one. So what's a number that can divide into 15 and 3? Well, 3 itself can divide into both. And so we can reduce that to a 5 to 1 ratio. So for 5 of the one thing, we have 1 of the other thing. All right, and a ratio doesn't just have to be a comparison of two numbers. You can actually have a 3-number ratio. You could have 4 or 5, however many numbers you want, all being compared. And again, you could reduce that ratio then by finding a number that divides into each of those parts. So in this case, with 10, 20, and 35, 5 divides into each of them. And so you could reduce that ratio to 2, 4, 7. So a 2 to 4 to 7 ratio. All right. Now we're going to get into some examples of when we actually use ratios, because right now we're just looking at numbers, but there are circumstances where ratios do appear. But before we get to that, let's just practice solving some equations. And these are things that are going to show up when we look at applications of ratios. So just like we said, we can reduce fractions. We can do the same thing with ratios. Well, we can even set up ratios like a fraction. So for example, if we have 20 to 26 ratio and we compare that to x to 13, we could also write this as 20 over 26 is equal to x over 13. So those two things are identical in terms of what it will mean for the value of x. And so now if we have it set up as two fractions equal to each other, we can just solve for our missing variable. So what is x in this case? So if we use our solving equations techniques, we can move this 13 over. So you have 13 times 20 over 26, because remember it's dividing on the right-hand side, so we need to multiply it to move it over. And if you solve that out on the left-hand side, what you will end up getting is 10. So x is 10, or 10 is equal to x. And you might be wondering, how did that get solved? Well, there is another way to do this as well. So another way, and you might have already seen this, is you could also think of this fraction like, how do we get from the one fraction to the other? So if you're going from 26 to 13, what do you have to do? What do you have to multiply or divide by? Well, you have to divide by 2. Well, if we divide the bottom of the fraction by 2, we could do the same thing on the top. So divide by 2, divide by 2. And, well, that would mean the 20 there divided by 2 will just give you 10. So that's another way that you can quickly solve that. But this, comparing the fractions, will always work. That's also why we have this other fraction here to solve, because fractions like this will show up. So 30 over 24 equals to 12 over x, or like a 30 to 24 ratio equal to 12 to x ratio. So if we want to solve this, we have x on the bottom. If we have two fractions equal to each other like this, one thing that we can always do is we can flip the fractions. So I'll just write that to the side. So if two fractions equal, we can flip them. Or the technical term would be we can take the reciprocal of both sides. All right, and then we can solve it like we did before. So move that 12 over by multiplying it by 12 as we move it over. And so we'll have 24 times 12 over 30 is equal to x. All right. And let's go ahead and solve this out. So 24 times 12, that's going to be 240 plus 48, so 288 over 30. And we can reduce that for sure. That will reduce to, let's take a moment to figure out what that's going to reduce to. Yeah, so we should have something like and we'll get something like 48 over 5. So it's not necessarily the nicest way it reduces down, but that is what we get in this case. Or if you wanted that as an actual like number, it's about 9.6. Okay, so let us continue forth. All right, now let's work with some shapes. So if we have something like a rectangle, sometimes you might know the ratio of the sides of the rectangle, but not all of the side lengths. So in this case, we're given that the ratio is 5 to 3. So let's just draw a rectangle. So when we're saying the ratio is 5 to 3, what we mean is you're kind of saying what multiple they are of each other. So if this was a length of 3, this would be a length of 5, or 5/3 longer, because it's not quite double. So it's a comparison of the side lengths. What we're actually told is that the longer side is 18. So we want to figure out what is the missing side. So what we can do is we know they have a ratio of 5 to 3. So, and we know that the actual dimensions of the rectangle will be in that ratio. So we know we can set it up as equal to 18 to some missing side length. And this is what we call a proportion, where we're setting ratios equal to each other. And we can actually write them down as fractions. And we'd likely want to have our unknown variable on the top. So we can rewrite this as 3 over 5 equal to x over 18. And if you rearrange, so move the 18 over by multiplying it, you're going to have 3 times 18 over 5 is equal to x, which, if you do 3 times 18, will just give you 54 over 5 is equal to x. In terms of a decimal number, if you want to figure out like what that's actually equal to, that would be about 10.8. And so that would be 10.8 centimeters. So yeah, if you had a length of 18 centimeters, the other side would be 10.8 centimeters if the dimensions of the rectangle are in the ratio of 5 to 3. All right, one last example. So this is definitely a useful example to go through. So we have two partners, Alex and Daniel, share the profits of a business in the ratio 3-7, respectively. So 3 to Alex, 7 to Daniel. And the profit for this year is $176,490. Okay, so how do we tackle a question like this? So what we need to do is, let's take a look at our ratio. We can also sometimes look at our ratio as parts. So a 3-7 ratio has, we can say, 10 parts. Because you have 3 from the 3, 7 from the 7, and 3 plus 7 is 10. All right, and so these parts are being divided and split up between Alex and Daniel. 3 to Alex, Daniel gets 7. But we need to know how much is each worth. And so what we're going to do is, to split up the profit to see what each person gets, is we need to use this profit and divide it by those 10 parts, and then basically give those 10 parts to the person that it belongs to. So each part equals, well, we have 176,490, and we can divide by 10 the total number of parts. So each part itself must be $17,649. Okay, so then what do Alex and Daniel get? Well, Alex gets, since it's a 3-7 ratio, I'll say 3 parts. And so that would be equal to 3 times that number. So 3 times 17,649. And if you calculate that out, what you'll end up getting is you'll have something like 52,947. All right. And then the next part, we have Daniel. Daniel's getting the 7 of the 3-7 ratio. And so if he's getting 7 of those parts, I'm just going to give some extra space here. We can do 7 times 17,649, which is equal to $123,543. And that would be in dollars. So there we have it. We've split up the money between the two. So if you have a total ratio and you want to figure out if you're dividing things between people, you can consider the ratio in terms of parts, figure out how much each part is, and then split it up based off of that. All right, and so that is an introductory look at ratios.